For nearly half a century, two robotic explorers have traveled farther than any spacecraft in history. Long after completing the missions they were built for, they continue their lonely journey into the darkness beyond our planetary neighborhood. Every transmission they send is astonishing. Their radio signals travel for many hours before reaching Earth, crossing billions of miles through the near-empty vacuum of space. By the time those whispers arrive, they are unimaginably weak, requiring some of the largest antennas ever built to detect them. Yet they continue to speak. Recently, engineers noticed something unusual. One of these distant spacecraft began sending corrupted information. Scientific measurements that had once arrived perfectly organized suddenly became confusing streams of meaningless data. The spacecraft itself still responded to commands, but something inside appeared to be malfunctioning. Considering its age, this wasn't entirely surprising. Designed during the 1970s, the Voyager spacecraft were never expected to remain operational into the 21st century, much less continue exploring almost 50 years later. Their computers contain only a tiny fraction of the processing power found in a modern smartphone, and every onboard system has endured decades of radiation, freezing temperatures, and relentless exposure to deep space. Many wondered whether the mission had finally reached its inevitable conclusion. Then came an unexpected breakthrough. After months of careful investigation, engineers successfully restored the spacecraft's ability to transmit understandable scientific information. Once again, measurements from the frontier of our solar system began arriving on Earth. The spacecraft was Voyager 2. Launched in 1977, Voyager 2 completed one of the greatest planetary expeditions ever attempted. It became the only spacecraft to visit all four giant planets, Jupiter, Saturn, Uranus, and Neptune, revealing worlds unlike anything previously imagined. When that historic tour ended, its journey continued. Gravity from the planets accelerated Voyager 2 toward the edge of the Sun's domain, carrying it farther than any mission had originally planned. Today, it explores interstellar space, a region where the influence of our Sun gives way to the environment between the stars. What makes this mission extraordinary is not simply its distance, but the discoveries it continues to make. Scientists once pictured the boundary surrounding our solar system as relatively straightforward. The Sun constantly releases a stream of electrically charged particles known as the solar wind. This expanding flow creates an enormous protective bubble called the heliosphere. Beyond that bubble lies interstellar space, filled with particles, magnetic fields, and material left behind by generations of stars. For decades, researchers imagined the transition between these two regions as a fairly smooth boundary. Voyager 2 has shown that reality is much more complicated. Instead of crossing a single clean border, the spacecraft appears to be traveling through multiple layers where magnetic fields, particle densities, and plasma conditions change dramatically over surprisingly short distances. The edge of our solar system is not quiet. It is active, dynamic, and constantly changing. These discoveries suggest that the frontier separating our solar system from the galaxy behaves less like a wall and more like an ever-shifting region shaped by powerful physical processes that scientists are only beginning to understand. As Voyager 2 continued sending measurements from interstellar space, researchers uncovered even more surprising patterns. The spacecraft detected unexpected variations in magnetic fields, changes that occurred much faster than existing models had predicted. Instead of remaining stable, the magnetic environment appeared to twist, bend, and reorganize itself over time. Measurements of charged particles revealed similar complexity. Some regions contained noticeably higher concentrations of energetic particles, while neighboring areas showed significant decreases. Rather than a uniform environment, interstellar space seemed divided into distinct regions with unique physical characteristics. Scientists believe these differences may result from interactions between the Sun's magnetic field and the much larger magnetic environment of the Milky Way. Powerful events occurring far beyond our solar system, including exploding stars and massive stellar winds, may send enormous disturbances through interstellar space. As these waves travel across the galaxy, they can compress or stretch the heliosphere, constantly reshaping its outer boundary. In other words, the edge of our solar system is not fixed. It expands, contracts, and changes over time as it responds to forces originating many light-years away. Voyager 2 has also recorded plasma waves traveling through this distant environment. Although space is often imagined as completely empty, it actually contains an extremely thin mixture of charged particles capable of carrying waves and disturbances across enormous distances. These plasma oscillations provide valuable clues about the density and structure of interstellar matter. The spacecraft has measured increases in neutral hydrogen and helium atoms drifting between the stars, helping scientists investigate the composition of the local interstellar medium. Even tiny dust particles striking the spacecraft at tremendous speeds reveal important information about the processes shaping our galactic neighborhood. Taken together, these observations present a remarkable picture. The space between stars is far from empty. It contains magnetic fields, energetic particles, plasma, dust, and complex structures interacting continuously across immense distances. Every signal Voyager 2 sends represents another piece of this enormous puzzle. Although each transmission takes many hours to reach Earth, every bit of information improves our understanding of how our solar system interacts with the surrounding galaxy. The mission has transformed our view of the heliosphere from a simple protective bubble into a living boundary influenced by both the Sun and the Milky Way itself. As Voyager 2 continues its silent journey farther into interstellar space, it carries humanity's curiosity into regions no spacecraft has ever explored before. Its discoveries remind us that every frontier we reach eventually becomes the starting point for an even greater mystery. Beyond the limits of our solar system lies a vast universe filled with structures, forces, and phenomena still waiting to be understood. And with every faint signal that arrives from the darkness, Voyager 2 continues expanding humanity's map of the cosmos, one remarkable discovery at a time.